Well, good morning, everybody. I won't go any further on my introduction, other than to say that in my experience, my background's not necessarily a strategic planner exclusively. I've also worked in project management and sponsorship. And I think probably the message above all we want to put across in this presentation is that there is a big focus here, rightly, on the major programmes, as we've heard here from Lisa, but also how that happens over time, including right now. So our traction power strategy in Eastern is not just about the promised land of a full electrification vision or decarbonisation. It's also about how we make decisions now, how they affect the railway today, and how the longer term decisions need to sit within that. So what we're going to do today is just explain the approach we've taken in Eastern to develop a regional strategy. And in particular, the focus here is on traction power, not just electrification per se. And the reason for that is, I think many of you will know that the simplistic understanding of our net zero programme is largely focused on the contact systems. But we need to understand the power strategy that sits behind that. And mindful of Rob McIntosh's points on the history, I don't think I need to dwell too much on what I'm sure many of you know has been a long, challenging feature of electrification in the UK, of that integration with the power that is needed to ultimately achieve the benefits of electrification. We've worked very closely in partnership with our colleagues in the regional electrification team, particularly Simon Thick and David Everson, who are here today as guests, and Kaitlyn Mair in our Network Rail NRDD design team, to make sure we've got technical reassurance in our strategic assumptions. So I'll give a little bit of context now into our team and industry strategy. I think many of you will be aware of route strategies, strategic advice that Network Rail produce. Ultimately, that's the gateway to achieving investment. That's not looking just at electrification. It's ultimately about outcomes. What do we want the railway for? What's it going to achieve? We made a decision in the last few years to change our strategic team, and we have one team called Network Planning, which, if you like, delivers that classic what do we want for Leeds, what do we want for Anglia, etc. And our team is Industry Strategy. And ultimately, the name of Industry Strategy, as hopefully you can tell from the name, is to look at the whole industry outcomes we need across the different components of the industry, and ultimately looking at that GBR vision of bringing those parts of the industry together to achieve more integrated outcomes and, of course, drive down that cost inefficiency that we've seen in different places since privatisation. One of our core tasks is managing the regional investment pipeline, and in basic terms that is a list of schemes. But of course what we want to do is recognise that there will always be different strategic questions and priorities at different times, and probably the theme and the name of this presentation, Minimal Viable Product to Strategic Viable Product, is about the reality that I'm not going to sit here today and say we cannot have minimum viable product. We need both minimum viable product and strategic viable product. And what I mean by that is we have to be cognizant of reality. And that's what I think Lisa and Rob McIntosh's points from Andrew Haynes reflect. We can have ambition, we need to know where we want to go, but we also have to be realistic within the funding envelope that we have at a given time. However, I think what I've learned in this period is that we must have a view of where we want to go because of the interconnected system that traction power is. We, in simple terms, have too many times in major programs assume that if we make a saving here, that will not have a bearing on another part of the railway. And of course it goes without saying that is absolutely not the case. It doesn't mean we always have to go to those strategic viable outcomes, but we need to know why we've made those decisions and how that affects our long-term outcomes. And of course, the obvious one there would be rolling stock and the separation within the industry that we have today. And I think it's really encouraging what Lisa was saying about the approval of funding on the southern part of the Midland Main Line, because clearly that will allow us to get the full benefits from the new fleet. So, our traction power strategy then. I should say I'm very grateful for the invitation today. Really, it's come from my perspective because we work with Peter Dearman and Bob Winfield in developing this traction power strategy for the region. I'll quickly summarise then those key details and the key headlines and then what that means for us going forward. So, ultimately, we need to understand that case for change. So, that starts with understanding our assets. So, like I said, we're not just talking about new capital delivery projects, we're also talking about the assets we need to maintain today. And that's a key thing that we need to be aware of, I think, in the strategy and indeed delivery and operations space. We're not just talking about new electrification, we are talking about our existing electrification, managing more services or different outcomes. And that's particularly sensitive with freight. Another one of our team's industry strategy objectives is developing a regional freight strategy, which ultimately is helping us work towards an anticipated freight growth target. I won't dwell much on what I'm sure most of you know, but clearly freight has a massive factor in our overall decarbonisation strategy, but also railway growth strategy. And I think Julian Worth will reflect on that later in more detail. The other thing that we felt we lacked was, we talk about industry strategy and integration, but also integration with our own region. So we've obviously got 4 routes within Eastern, but also different functions, capital delivery, engineering, etc., operations. So we've established a traction power management steering group for the region. And ultimately that was originally designed to pull together this strategy, confirm the assumptions and the objectives we want to do together. But we intend going forward that it's a forum where we can present new proposals as they develop and clarify those assumptions against a sister product of this traction power strategy, which is a capability report. And I know that sounds, well, I'm sure you know the capability of assets. I'm sure we have historically, but we put them in one place. And one of the key things we want to work towards, and I'm sure you'll hear in our sister regions presentations later, is delivering an annual traction power statement to our customers, so we are aware of the capability of the railway today in summary, but also the key assumptions as enhancements develop in different configuration states or working towards the end state. And that end state is that pathway to wider electrification. So in simple terms, great, we've got a TDNS, and GBR, Great British Railways, have a similar product that's being developed. But what we have historically lacked, certainly in the time that I've been looking at this, is that we also need that strategy to understand the interventions with someone beyond the industry as well, the electricity supply industry. And I think that partnership approach and understanding those interactions and interfaces, that we are having a strategy that is delivering growth and electrification, but we're also reliant critically on another industry that is itself adapting to change. So the same 2050 STK challenge that we have is their challenge, and we are one of many customers who wish to have more power. And we all know there's lots of different demands for that, data centres and electric cars. And then I think there's that requirements and system integration piece. So Kaitlyn will talk a bit more about the technical points of that, but in simple terms, have we got good modelling that allows us to understand what we're doing today? And then inform the decisions that we make at each stage of the life cycle of projects and operations. I won't dwell too much on the East Coast Power Supply lessons learned because it's probably a subject and a conference in its own right. But I think the simple headline to say is projects like the East Coast Power upgrade are indicative of why we are keen to develop the strategy we have. In simple terms, the strategy has changed over time, and again, that's okay. But where that strategy has changed, as timetable requirements have changed, different open access operators or other changes, we need to make sure that strategy is amended to reflect that. There are also, I'm very grateful to be part of your tribe today, but I've realised in this that there are tribes of power philosophies, be they AT, Classic or SFC, and there is no right or wrong answer. They all have a place, and the East Coast Power Supply, in very simple terms, is a collection of these. However, we need to understand from a strategic perspective, in terms of that whole life cost implication, what each of those means, and why, for example, an SFC has given us a trade-off of allowing us to take power supply within a manner we didn't have before, but it also has operational implications in new maintenance philosophies, for example. And it goes without saying that ultimately the report that Rob mentioned earlier for East Coast in 1991, there's 32 trains, electric trains at the time, we're now 85, so it's exponential step change. And the strategy is ultimately about saying, well, if that's a big step change, then we are talking a huge further step change. The image there in the bottom left as you face it is about showing that we have that pipeline, but within the traction power system there is a relationship between programs and different service groups over time. So, for example, we may be putting in power supply up to Leicester or Sheffield, Nottingham, but some of that power supply may be feeding, for example, the future electrification of the Clay Cross routes. Now, those are difficult decisions to make, and I'm sure Lisa's team are having to make difficult choices now with the DFT about whether we can afford all of those kind of strategic platforms. But at the very least, we want to have that conversation, understand why we've made those decisions. So, in summary, what's the punchline? So there are 46 power supply points today in the Eastern region, and our strategy has concluded we will need over time to meet our 2050 electrification targets, and that's basically built on our Eastern region electrification strategic advice, which is the Eastern's version of TDNS, basically, in simple terms. 35 to 38 new traction power supply points. Now, I think one thing that's really apparent to me in this is that STK, we talk about the STK rate. I really feel, from my experience, that the factor of the power within that STK rate is underestimated. And I'm sure many of you know the costs with the bulk supply point and the feeding architecture are a significant part of that. So 35 to 38 new supply points over 30 years is a significant investment in its own right. But also, as I said earlier, when we're talking about, for example, we will have a service on the Transpennine core route, that service will then go somewhere. Julian will talk about this in great detail, I'm sure, with freight. But that's the case for passenger operations as well. Is it going to Cleethorpes? Is it going to Blackpool? And whether it's somewhere that's got an existing supply, like I think Blackpool now, say, or needs its own supply in future, we need to be aware of that. So we also think we would need upgrades to 15 existing supplies. I think a lot of the points within this slide I've talked about already. I think it's just worth saying that, a key thing to think about with industry strategy is we're talking well beyond engineering in its own topic. We will have lots of presentations on that today. But access rights, for example, and how they are granted in the railway network code today was not designed to consider electrification. So we're having a, freight again, we have a challenge with the bi-mode technology coming forward, and the assumption that we can supply that power at any given time. And I think, to quote a wise philosopher, the simple answer is yeah, but no. There is undoubtedly periods of the day when we will not be able to support that with the current supply as it is. But equally, there are different parts of the day when we can. So what we want to do here is not just put a strategy, it's on a shelf and, round of applause. It's a live document. It needs to keep evolving. And also, we can't always assume that capital outcomes are the answer. They often are, and clearly the message today is we need a lot more spending. However, we have seen already in this process that, we think we need to do all this work at a location somewhere in the region. Has anyone asked the electricity supply industry if we can just uprate the supply? Or does the contact systems and everything else support it? Yes, it would. Right. How much does that cost? Under 100 grand. So it's not always about capital expenditure. And it may be, of course, within a major programme over time about configuration states. So really, we need to be aware of those key things that are ultimately driving requirements. What's the timetable? What's the rolling stock? And I think it's also about awareness and competency within the region. And, not just at the capital delivery level and sponsorship, but just some basic awareness of the interdependencies between our requirements in the industry, what that means for the different components, be that rolling stock, maintenance, or indeed further with our partnerships in the ESI. So very simply then to finish, we have designed this work so we have a strategic framework to make decisions. It's not the answer, but we cannot make decisions and achieve the cost efficiencies that we wish to without having that framework. And ultimately, strategic planning is about trade-offs and choices. And we will, as is the case on a major programme in Eastern, which shall remain nameless, have difficult choices where we have to pare back funding for power supply. But at the very least, we need to understand why we're doing that and what the implications are and what that means. And our operating model then is, and this is a good example perhaps of Project Speed, we're not trying to create a cottage industry here, it's bringing together existing people to make decisions similar to what you may have in safety review panels or that kind of structure, or investment, sort of a hybrid of the two. At the moment, we're probably more of an advisory body that supports that, but that could change as more work continues. And then ultimately, it's about driving forward the instinctive industry leadership we've sought to show here, and hopefully setting ourselves up for success. And of course, I should stress that whilst this is an Eastern-centric presentation, the great thing about this is that other speakers today are part of a community in Network Rail that is now looking to how we embed this and also how we influence the DFT to understand this. And I think the big takeaway for me is, I know you may think, it's a very nice thing to say, but it's very challenging itself. The Department for Transport is governing our outcomes. The Department for Energy, or whatever it's called now, is supporting the ESI. So if we can understand the opportunities at that headline government level for net zero, that could drive further efficiencies in the programme we see today. So, for example, the one thing that's always struck me is we always come as Network Rail as a single customer for a power supply point. But if we're looking at a power supply point near Sheffield, a heavily built up area in South Yorkshire, could we be part of several customers? So innovation doesn't have to just mean technical innovation. It could be contractual innovation or governance. And really, so we've got that framework. We want to go further. How can we get better at understanding the different tribes and how we can do different engineering options? But there's much more granularity within the traction power system and overall railway system behind that in operations, performance and resilience. So, for example, depots and stabling. Are our depots and stabling electrically independent? Do we want that? Is that supporting our performance regime? What's our SCADA strategy and how does that support our outcomes? Innovation, as I said, it's not just about the sexy engineering, it's also about the operating practice and the process and the culture. And I think it's really exciting that some operators have started approaching us when at the start, before they've even considered a rolling stock procurement, which is, I'm sure you all agree, very sensible. That hasn't always been the case, or it's gone to one part of Network Rail and not to the other. And then ultimately building better business cases. I couldn't agree more with the comment earlier about the perversity of certain criteria. Again, some of the things we've seen in this process is business case submitted with, we've not included the diesel fleet savings that would bring in a year, let alone the life cycle of a business case appraisal, which I thought was the whole point of the business case. So, of course, we can't change that overnight, that's the Treasury, but our role in strategy is to put forward those points and hopefully influence, as part of our team's role, the Great British Railways transition team. So, thank you very much for listening today. Thank you very much for the invitation. I shall hand over to Kaitlyn to explain the technical assumptions behind this work.
Good morning, everyone. Tom has given us a really good outline of the case for change, and what I want to talk to you about this morning is what we as engineers need to do to give Tom and Co the tools that they need in simple language to convince stakeholders that decarbonisation is the right thing, because often what we're doing as engineers is far too complicated to explain. So how do we do that? First and foremost, in my view, we need to not fall down the rabbit hole of crossing every T and dotting every I, because if we go into that level of detail, we will be there forever. So my 10 plus years working in traction power hopefully mean that I'm qualified to give you today's sort of whirlwind tour through how we actually developed a strategy and stayed above ground without going into too much detail myself. So how do we make a regional traction power strategy that goes from today's electrified network, where you can see certain core routes electrified but not a lot else, to a fully decarbonised network, which is very integrated and potentially has a lot of crossover. So first of all, we need to make a lot of assumptions. I want to list some of them so we can come back at the end and see how they've sort of lasted the test of time in the railway. 2 years, that is. So first of all, HS2, well, that was going to be on a dedicated route from Leeds to Manchester when we worked on this. NPR, that was going to be tunnelled from Manchester to Leeds, possibly 140 miles an hour up the East Coast Main Line. Passenger service growth, that was going to be in line with pre-COVID growth patterns. Freight, we've talked about that already today. We were anticipating modal shift, moving from diesel to electric fleets, and potentially bringing some off the road onto rail. East-West Rail, that was going to be built all the way from Oxford to Cambridge, not electrified, we assumed. Crossroad 2, that was going to be built too when we were working on this, so from West Anglia to Wimbledon. We had to make assumptions around rolling stock, what if anything there would be of hydrogen or ammonia trains, battery trains. But we also needed to shift our, the other things we had to do was shift our mindset and move away from traditional design methods to higher level sort of assessments, and we needed to approach the problem as if it was from a blank canvas. We needed to throw away today's constraints and problems and think about a system that was free from those. So what do I mean by a mindset shift? So in order to produce a successful strategy, we needed to move away from that detailed thinking to something more like order of magnitude thinking. What do I mean by that? If we did a normal traction power assessment, we would know the timetable down to the minute. We'd know the exact routes the trains were running on. We'd know what junctions they were crossing when. I'd know all about the rolling stock, down to its weights, how long it was, how that weight varied if there was different passengers, what the wind resistance of it is, and I could go on and on. But that wasn't going to work for a strategy. We had to look at it differently. We also needed to take a more sort of flexible approach to developing the strategy. We'd still be working on it today if we'd gone down the normal approach. We also spent some time thinking about what we could do differently. So we were starting from blank canvas in our minds. So we got our magic 8 ball and we had to think about what new systems and technologies might be there in 30 years' time. Things like high fault levels in classic systems, Scott or LeBlanc transformers, to reduce fault level issues in the network, running HV links along the AC railway, much like the Southern DC network. And after a bit of thinking, we decided that while they were all good concepts, the best approach for us for a strategy was one of being technology agnostic, because that left all paths available. So how did we get from A to B? How did we get from a blank sheet of paper to something that actually looked like a decarbonised network? I could talk you through that, but actually it boils down to something much simpler. It's two key fundamental questions of how much power do we need and where can we get power from? Once we've answered those, we can begin working through options and pulling together a coherent system. So, to answer the question of how much power do we need, we developed 14 generic timetables, and we modelled them like we would normally. So we built, in our modelling software, a nice little test track, and we built some generic timetables on there. And they range from very dense commuter-style networks like you see in London to very low sort of regional networks like you would see between York and Scarborough, for example, and everything in between. And then we broke the network down into over 200 segments, and we matched timetable scenarios against the long-term timetable forecasts we had. And that gave us a quick and easy way, and also a flexible way of coming up with loads per route section of the network, because we could very quickly change it and ask ourselves the question of, well, actually, if the network in Leeds develops even more, can we? What happens if we want to increase the power on that network? So once we had the two, we combined all that together. We had load estimates for the region. And then to answer the question of where could we get power from, we needed to find options, and we did that using open source data from that's readily available on the internet, long-term planning statements from the DNOs, and we used that to identify all grid sites in Eastern region that were within a reasonable distance to the railway. And by reasonable, I mean 5-ish kilometres. We don't want to connect much further away than that if we can avoid it. And then we used a RAG assessment to filter those out. You can see that up there for a sample of the network. And we used factors like available capacity at that grid, how close it was to the railway, and how easy it was to expand. Was it on greenfield? Was there lots of space in that grid site? Sorry, getting lost in my notes. And then when there weren't any viable connections, we had to go back to the strategy and the initial plans, and we had to look at alternatives. Could we look at alternative traction supplies instead of electrifying that route? Could we partially electrify it, use things like line-side storage, or create our own power supply for those routes where there weren't any? And then the next step was, once we had an idea how much power we needed and where we could get that power from, we used a framework of design principles, some of which I've put up here, to help begin to guide us on where we could put those supplies. And some of those principles are really obvious. We use them today. Achieving N-1 redundancy, so you can have a key piece of kit out at a site without everything falling over. But even with that, we tried to break from norms at times where there was a lack of strong supplies. So we looked at achieving N-1 differently by having 3 small supplies in one route instead of 2 dual supplies like we normally would. We also we looked at some other principles. 2 most important probably were maintaining route independence, making sure that on primary routes like MML, GNG, ECML, that we had feeder stations to supply them and they weren't reliant on other routes. And secondly, principles around the amount of load available in feeding distances. So I've tried to summarise it in the table there. Starting from the highest sort of voltages, the transmission level. These have historically been our strongest supplies. We use them on sort of the main routes like West Coast and East Coast. And yeah, they've historically been our strongest, but actually they're tending to be a bit weaker these days because of changes at a generation level. But these are generally used for AT supplies because they get the highest capacity. They can feed 100 MV and up to 50 kilometres in each direction. When we stepped down to lower voltages, you had options like SFCs at high capacity, 132 or 33 kV sites. And they can feed up to 40, 50 kilometres from a feeder station as well. And then moving on down, where there was less capacity at a supply connection, we had to look at more conventional options like single-phase transformers like we use today, or small SFCs. And then to maintain an agnostic approach, we produced 2 options of outputs. One that was centred around those high capacity 132 DNO connections, and one that was centred around a more traditional transmission or weaker DNO supplies. So after all that, we could begin producing some outputs. So we've got some engineering outputs up on the screen there. One's outputs with lots of numbers, shiny pictures, or single line diagrams, to be a bit more technical. And those single line diagrams began to tell us the pattern of where we could put supplies that had enough capacity and how many of them we'd need for each route, how far they could feed and how everything interconnected. And they could tell us where we needed to put auto transformer systems or what system types we needed. And that began to give us a picture in the tables of how that looked, how much load we'd need at each site, and how that would grow as the strategy was delivered. That wasn't really what Tom or Peter or Rob really need, though from a strategic point of view. So we also produced outputs that could actually tell a narrative and produce a story. Things like how many new supplies we need, like Tom was mentioning, or kilometres of AT, the kind of fundamental things for coming up with high-level costs for this. My favourite of those is probably the chart there, because that gives us a picture of how the load moves through time. So we moved from about 500 MV today of used capacity on the railway in Eastern in a peak period, to a projection of, if we electrify everything, about 1800 MVA, which is over a threefold increase. But perhaps the most interesting thing I find about that graph is you can see in the tier 4, the purple ones, that it doesn't, and even tier 3, they don't add a huge amount of load themselves. But what you see is a great knock-on impact in the higher priority tiers, and they keep growing right through to 2050. And that's something pretty fundamental that we identified and we fed back, that there's a lot of upgrade that will need to happen to the existing network, even beyond what we've done today on routes like East Coast, to give us the resilient power supplies that we need along the route. So I'm almost done now, but as I said, I wanted to come back to assumptions and look at how they've survived that test of time. So HS2 and NPR, well, yeah, they're more reliant on the existing network than we had assumed, but actually we kind of could see the writing on the wall at the time of writing, so we produced different scenarios that looked at that. Passenger service growth, it's definitely growing, but not at the traditional periods. If I was presenting on the capability reports today, we'd have some really interesting graphs that shows the load flattening out, load going up in the middle of the day, but dropping down in the mornings where we would normally see that peak load, and again at the weekends, which has a big impact on how we're operating the railway now. Freight modal shift, it's definitely progressing. We can see that with procurement with the 93s and 99 fleets. And Julian will have more to say later, obviously. East-West Rail, that one has actually survived. I don't think any of our assumptions have changed on that, which is positive. Crossrail 2, well, yeah, that has changed. It's been paused. Not sure when that will move forward. And then rolling stock. GBR, and we're doing some early work with them on this, are developing a rolling stock strategy, and that will hopefully inform us a lot more about what the future of hydrogen battery trains is. Looking back, I'd say overall we've not done too badly with those assumptions. They've changed a lot in 2 years, but some of that we could predict. So just to wrap up today then, what comes next? So as Tom has alluded to and I've mentioned, we're currently drafting traction power capability statements. The aim of these is they're simple 2-page documents that tell us the health of the network today. And we'll be publishing them probably Q2, Q3 of this year to tell us what the region actually, what the health of the network is today. We need to keep integrating the fleet and infrastructure. I think that's been talked about a fair bit already today. And hopefully that's where GBR really can come in and deliver some real value. We need to integrate and align the strategy that we've developed with the current programmes. And actually, it's been really good already to see projects like Northern Powerhouse come to us and ask what the impact of what we've put in these diagrams is on them. Do they need to do anything? And then innovation. We need to keep developing the traction power systems to take advantage of some of the rapid advancements we're seeing in battery technology, and look to see if we can reduce the scope of the strategy and cut down the number of new supplies that we need to make it more affordable. And then one last thought, because I think we're guilty of this quite a lot, is the strategy is just a blueprint of what the future might look like at a snapshot in time. And as I've talked about today, things change rapidly, circumstances change rapidly. And if we let ourselves stick to something because it's written down on a piece of paper and we don't adapt, we're going to fall into the same traps we've always fallen into. So we need to be flexible and we need to challenge what's in that strategy, because it's just there as a guide, and it will definitely not be built in completion. Anyway, thank you for listening to me. Rabbit on for a little while and I'll let you sort of ask your questions now, I think.